they make the mathematical statement
It's in
true.
the trash can.
But you added extra that was not 100% accurate.
Good,
You gotta be careful. A 5.5 is good, Kelsey. I really don't know why you're complaining right now.
No, but I just don't understand why you.
I just explained it. Okay, so please do notice, right? That's the basic idea here. How do we determine if there's solutions? What do I need to do with this -3?
Substitute.
Substitute it for
X.
x. Hey, attention. What's going to happen with that 6?
Substitute for Y.
Substitute it for y, right? So -3 times -3, that was x, plus 6 times 6, that was y, plus 5 is equal to -7. Gives me 9 plus 36 plus 5 is equal to -7. Is 45 plus 5 equal to -7? No. So is -3/6 a solution? No, because that statement is false. Okay? I'm going to leave the rest to you on that one. We go with that idea. Huh? 5, I think, is still an A. But I average all the scores. Okay? Quick question, are we good on number 6 after all the bell ringers we've done with stuff like this?
Yeah. I got 3. I have 4.5 though.
Well, also I do want to point out, we should be able to create an equivalent equation.
Yeah.
But what do I mean by an equivalent equation? This is where a lot of us missed our ideas, or missed points. What is an equivalent equation?
They're the same, they just look
They're the same, but they
different.
look different. That look different, but are effectively or are the same.
You left me with a fill in the blank. I don't know what that means.
Yeah, because I gave you 90% of the work. I'm saying this thing is what you're missing. Think about it. Okay? Guys, an equivalent equation is there are equations that look different but are the same, which that works for any equivalent equations.
Hey, bro, what you got?
Only when it's, hey, stop, dude. Focus.
Man, son, these my
Focus.
popping bottles in my hands.
No. Focus.
Man, this
No. I have no clue what you just said for the last
Man,
minute.
say
Pay
that.
attention, okay?
Man, stay, you know what I'm saying, man?
So, equivalent equations do have the same solutions, but what we really mean is that they look different but they're the same. And what are the properties that can be used to create such equations?
Division.
The property of equality.
Properties of equality, right? Which are the division properties and
Yeah.
addition, all that stuff. But properties of equality, what else? Commutative. What else? Distributive. That's it. At least that's all we've done, right? The properties of equality are the commutative, or the properties of equality, the commutative property, and the distributive property are how we are making equivalent equations. Okay. And then the last detail, I need y'all to focus on this, okay? Jonathan Joestar is an extremely wealthy and generous man. He has decided to provide free meals each day over the next year, right? On the first day, he gives out 6 meals. Every day for the rest of the year, he gives out 4 more meals. Hopefully you see the equation there, because I see repeated addition. Where? The 4 more every day, right? So what are you going to do with that 4? You're going to be multiplying it, right, by something, okay? But if you don't see the equation right away, what could you make to help you? A chart, a table, right? So based on the day, we have this number of meals. Day 1, how many meals were there?
5.
It depends on which quiz you had. I think some of y'all had 5 and 3, some of y'all had 6 and 4. But for this one, we're starting at 6 meals. Yeah. Some of y'all had version A, some of y'all had version B. Okay? Day 2, he gave out how many meals? Nope. 10. He added 4 more, right?
Version are you on?
I don't know what version this is. But if you had the other one, it would just be 5 and then plus 3, right? Day 3, he gave out how many meals? 14. Day 4? 18, right? Notice how there's starting at 6, so the number of meals is equal to 6. That's where he's starting at, right? And then what's he doing to those number of meals?
He added.
Repeatedly adding 4. So 4 times.
10. You said 6 plus 4 is 10. I thought you asked for an answer.
No, I asked. Remember, 4 is being repeatedly added.
Yeah,
So we need to multiply it by what?
Times, I don't know.
Time X.
Times x, or I might do
D.
d for the number of.
Day.
Because every day he's adding 4 more meals, right?
Yeah, true.
Okay.
What's that? Again.
So then why?
5.
Did you answer the actual question of how many days does it take?
I said X.
Okay, so look, I have not answered the question yet because the question was how many days does it take for him to give out how many meals? At least for this one. 134. Where should that 134 be substituted in?
M.
For M, the number of meals, right? It's going to be substituted for meals, not days. And so 134 is equal to 6 plus 4D. From there, 1, you were supposed to explain the equation. Did you do that?
Yes, I did.
And then 2, you were supposed to solve the equation. Did you do that? No, you did not. Because you ran out of time and you even made the note on there and I remember it. Because I pay attention to my students.
Hey, that's on what?
Okay.
Big one.
So, please notice, I looked for my repeated addition, and that's how I wrote my equation. We need some practice with that though, yeah? And practice solving equations?
Yeah.
Okay, maybe.
I need better
So-
justification.
Let's look at lesson 9.
What page is it?
Actually, quickly, lesson 8, I do want to point this out. Do not forget that you can have repeated subtraction as well, right? Remember this. So hold on, just pay attention up here. I'll give you time to get out lesson 9 in a second. With number 3 on lesson 8, remember how we had tank B and it had 80 liters coming out every single day? Or, sorry, it started with 80 liters and how much was coming out? 2.5, right? So at minute 0, so minutes and I'll say W for water. Minute 0, how many liters were there? 80? Right? Okay, and from that 80, at minute 1, how many were there? 70 what? I don't think it was 75.
Down 4.
78.8.
Down 4.
77.5?
Wait.
7.5. Then
Yeah.
we need 7. No.
Terrence.
What?
Yo, what is happening to the 80 liters of water?
Then all the body.
Being drained by 2.5 liters per
They
minute.
get subtracting.
What's 80 minus 2.5?
75.
0.77.
Man, that's what I'm too.
You get 75. What?
Okay.
0.
At minute 2, it would be
75.
75. Minute 3,
72.5.
minute 4.
40.
What? 70?
Oh.
Okay. How could I represent what is happening here in lesson 8?
Subtract. Yeah, you're subtracting liters by.
Repeated subtraction.
I want to say it wrong.
I mean, yeah, I am repeatedly subtracting, but like, how am I going to represent this with an equation?
God.
Huh?
I mean, 80 minus 2.5.
Okay, so I've started with an 80, didn't I? 80 minus 2.5
Times X.
times x. I would probably use t because they said t minutes.
Yeah.
Terrence,
Yes, sir. All right.
attention please. Thank you, sir. So what is represented by 80 minus 2.5 t? Liters of, so I could make it equal to, no. We good with that idea?
Yeah, what's up?
Okay. So I need y'all to remember this. And I'm going to show you one more thing before we get to lesson 9. Okay? You don't need to write this down, but I need you paying attention so that you can think about it later. Okay? So, notice with number 3, we got L is equal to 80 minus 2.5t. What is this equation good for?
Finding how many liters are being drained.
Not how many are being, actually, you already know how many is being drained each minute. What is that? 2.5, right? What is this equation giving us?
Minute.
80 minus 2.5. C is, wait. Same thing.
Oh,
Hold on, but I think I know the answer.
Minute, T is minutes. Trying to find liters.
We're trying to find the liters of water based on what?
On the total.
Based on
The
the
solution.
On the 10 minutes.
the minutes that have gone by, right? So, listen y'all, this would be finding the liters of water based on, I hear talking going on behind me instead of paying attention.
Michigan.
Focus. You need to actually learn something. I'm trying to teach it to you.
Michigan, can I come solve it on the board?
Finding the, nope, because we're not, it's 2 variables, dude.
I'm not
Finding the liters of water based on T minutes. Okay? This is an important idea. Finding the liters of water based on T minutes. So if I knew the number of liters, what would I do in number 4 here? If I knew that it was 75 liters, what could I do with this equation?
Plug in liters.
Plug in 75 for the liters. So for
L,
L,
75.
does this equation work well when I'm trying to find the time? Is it ideal? Remember, I was able to just substitute T in here and automatically get the liters, right? Can I automatically get the liters here? No. So, spit your gum out.
Oh.
You're distracting people by trying to blow a bubble and get them to look at it, dude. Okay, so this equation is not super useful when I want to know the time. We good with that idea? We good? So, is there a way for me to get what T is equal to? Can I use this equation to figure out what T would equal to in every situation based on the number of liters? Okay, let me ask you this. Could I subtract 80?
Yes.
Why would I want to subtract 80 here, Gabe?
Last thing.
I mean, it might help me get to time, but like, what am I going to do when I get 80 minus 80?
0.
Oh, so why would I want to subtract 80? Because it's going to create a 0. Can I subtract 80 just from the right-hand side?
Nope.
No? So I got to do it from both?
Yeah.
Okay, so how would I write the left-hand side now? No, left-hand side.
L minus 80.
L minus 80 is equal to
Negative
Negative
2.5.
3.5.
negative 2.5t. I'm pretty close to getting what t is equal to now. What could I do at this point?
2.5.
Not adding.
You want to
What?
subtract?
No, you divide.
Not subtracting. Say
Divide.
again. Dividing. What's happening between negative 2.5 and t?
They can divide it.
They're being multiplied. Even though there's a negative there, there's multiplication, so I need to undo that with division by negative 2.5. So now I have, hey, oh, by the way, what is negative 2.5 divided by negative 2.5?
Zero.
That's a
1.
1. So 1t is equal to. Now can I easily figure out what the time is equal to?
Yes.
Are these equations equivalent? Yes. But is one better in certain scenarios?
Yeah.
This one was really good when I wanted to find the liters. This one's really good when I want to find the time. Okay? So this is why it's important to know how to get equations that are equivalent, because sometimes you want one equation over another. Those expo markers are to go on the board or on the desk. It messes them up when you write on your binder like that. Or whatever paper that is. Okay? So, we all good with that? Okay, we're going to use this in lesson 9. So, get out lesson 9. This is the bottom part of the front page. It's about shipments of cars and trucks. I believe we already wrote an equation for this. So we should be looking at lesson 9.
Mr. Kenny, I know.
Yep, it's 9.2 cargo shipping.
Mr. Kenny.
That's it right there.
Kenny.
9.2 cargo shipping.
I lost him.
Can I have another
No, that's
eight?
good.
I know I did, I just don't know where it is. I got 9.
I got 8. He got 8 right there. I kept up with it. I don't know if I kept up with it.
That's the first page of lesson 8.
Did it hurt?
Okay.
Oh, wait, we here. I'll collect in a second. Yes, lesson 9, where it says 9.2 cargo shipping. We should all have it out now. Ready?
No.
Tabamanos?
Yeah, let's vomit it.
Let's go.
Go.
It's like a mixture, it's a Spanglish way of saying it, I guess. English and Spanish. Alright, really quickly, I need everyone's attention up here because some of us need to write this down probably. Does anyone need a copy of lesson 9?
Yeah.
If you need a copy, come get it. It's 9.2.
Get up and get it, Caleb. So what's the paper?
There you go. Alright. So when I look at number 1, right? So if we remember, we have a manufacturer that's preparing a shipment of cars and trucks, and it can carry 21,600 tons on the ship. Each car weighed how much?
3.6.
Okay? Each, right? And each truck was
30 something. Oh, 7.5 something.
Is there anything repeatedly happening there? Repeatedly adding what?
Addition, probably.
No. What? Does anyone see anything being repeatedly added?
No.
Nothing? In this context of we're putting cars and trucks on the ship? Okay,
Yeah.
but if there's multiplication, there's repeated addition. What is being repeatedly added?
Add 2 cars.
2.5. 7.5 cents.
Tons. 3.6 tons.
3.6 tons for each what?
Car.
Do you know how many cars?
Yeah.
No. Which is why when we wrote an equation, we said 3.6,
T
not T, C,
plus
remember times C,
the
plus what?
7.6.
7.5 T is equal to
21,000.
21,600. Okay?
Yeah.
We all good. Do we see the repeated addition happening in that equation?
Yeah.
And where it's coming from in the problem? Is this equation really useful for finding the number of trucks right away?
No.
No.
What did we need for it to be really useful to know the time right away? We needed T by itself, so T equals, right?
Yeah.
Do we have the number of trucks equal to something?
No.
No. Right? Can we use it? Sure, but it's not going to be super useful. Do I know exactly what the number of cars are right away?
No.
No. So is it super useful yet?
No.
No. Okay? So what we now need to do, right, number 2, find the number of cars that can be shipped if the cargo already has 480 trucks. So what are you going to do with that 480 right away?
Multiply it by 3.6C plus 7.5.
So you're multiplying the 480 times this whole thing?
No.
You just
I
said
said
the whole
no.
thing.
No, look. So I did 3.6C plus 7.5 times 480.
Okay.
Equals 21.
Terrence, why is Matthew multiplying 7.5 times 480?
Alright, I got you, because it's tens of each row.
Well, we already knew that up here. That's why we did 7.5t. So why is it 7.5 times 480 now?
No.
Oh, you could help yourself when you pay attention when Matthew explains it.
Okay.
Okay? Brandon, do you know why?
Nope.
You were looking up here. My question is, why is that 7.5 now being multiplied by 480? Matthew already explained it once.
Oh, I got it. I know now.
It's Brandon's shot. Chance, you had a shot.
The dude, the racing.
Okay, it is going to help us find the number of cars, but why would we do 7.5 times 480 to start? Yo, I can't even hear Brandon because people are making noises instead of giving the man the respect to listen to what he has to say. What's your question? Or what's your statement? Okay, but why are we multiplying? Someone else, I need some more ideas about why those two things are being multiplied. Josh.
Cause you gotta find, I don't know. All the stars and actually. Wait, say it again.
Why is it no longer 3.6c plus 7.5t? Why is Matthew saying we need to multiply 7.5 times 480?
I know the exact.
Ireland?
480 is the trails and it's.
Substitute?
Yeah, substituting 14.
480 is the number of what?
Trucks.
Trucks. So what is it getting substituted in for? The number of trucks. That's it, right? We need to recognize that. Do we now have any